P, I don't like the P and Q, but okay, fine. 5 minus Q, so this is 83 on page 61. So, and P equals the square root of Q plus 7. So let's go back to my initial graph just to discuss this for a moment. Notice what happens here. For this particular number of units, let's say 10 units, the price per unit, everybody's happy with. But the Y value is the same for both. So at this point, this is the X value, and both functions are equal to each other. How much? They're equal to B. So how do I determine the equilibrium point? What do I have to do to find that? So we're asked to find the equilibrium point. At the equilibrium point, the demand function and the supply function, as you see, is this even the same letter. Demand equals supply. At the equilibrium point, the two functions have to equal each other. So then 5 minus Q equals the square root of Q plus 7. We're using substitution. So basically, I replace this P by 5 minus Q, same thing. And now I have to remember what, first of all, identify number one, identify this equation. And once I know what it is, think about how to solve it. So what type of equation is this? Is it linear? Is it quadratic? Is it rational?
Professor, is that linear?
This is a linear expression, but this is not linear.
Quadratic.
Yeah.
Quadratic would have looked like this. This is quadratic. It has to have something squared. If it doesn't have anything squared, it cannot be quadratic.
Right. So rational?
No, because it doesn't have a radical. It doesn't have a denominator. This is rational.
Okay.
So let's read. Let's read the equation, because we have the clue is right there. So I will read it, or if anyone else would like to read it. 5 minus Q equals the square root of Q plus 7. What type of equation is it? Anyone? Okay, so let's go back to the analysis from last time. We looked at 3 different functions. We looked at this one. We looked at this one. And we didn't look at this one, but we said it's friendly. Any quadratic, linear, everything goes in there. So which of these 3 you find it here? Which of these 3 expressions or functions you find it in here? What do you think? Anyone? You want me to show it again? We looked at 3 functions last time. Not really, but linear, quadratic. We looked at this one, and we looked at this one. Is any of these 3 in here?
So radical.
Thank you. Thank you very much. Who was that?
It's Donna.
Thank you. Excellent. How do I solve a radical equation? What do I have to do? Anyone remembers what we do when we solve a radical equation?
Square both sides.
Thank you very much. Yes, we square both sides. Good. We start from the left. How do I square this and how many terms do I get?
4 terms.
Not possible.
Sorry, 3 terms.
Excellent. So, what are those 3 terms?
Q squared. 25. 5Q and negative 5Q. Oh, wait, no.
So we talked, yes, you're on the right track. So we talked about this formula, the first term squared minus 2 times the first times the second plus the second term squared. Good. Can anyone square the other side for us? Excellent. Thank you. Can anyone square this?
It should just be Q plus 7.
Of course. Now it became quadratic. Move everything to one side. That's what I have to do with quadratic. And put in the correct order. Q squared minus 10Q minus Q minus 11Q. 25 minus 7 plus 18 equals 0. I want to show you, and I will record this. Not all calculators have this feature. So where is my recording button? My recording on this computer, yes. Okay, so we go to apps, and we choose number 9. And we're choosing the polynomial root finder. Order, I don't know why they wrote order, it should be degree, but it's okay, so degree 2, because it's quadratic. And then we continue, and we fit in, and we put in all the coefficients in the correct order. That's why I already presented my equation in the correct order. So the first coefficient is 1. The second coefficient is negative 11. Use the negative symbol, not the operational symbol. And the last, of course, we don't need to do this. I just wanted to show you because it's too easy, but I wanted to show you. We know that it's negative 2 and negative 9, and when we solve them, it's going to be 2 and 9. But we want to see this, okay? So you entered correctly 1, then negative 11, and then 18. And then click on graph, and it gives us the solutions. So you can use this feature if you have it in your calculator. It's the polynomial root finder feature, and it's under 9. So I am going to stop the recording, and I'm going to post this. Okay. So then the 2 solutions are Q equals 2 and Q equals 9. Now, please remember, of course, this was too easy. So Q minus 2, Q minus 9 equals 0. So that's how we get these 2 solutions. But I wanted to show you the feature, the apps. Okay. The next thing that I would like to do, we need to do, every time we square both sides, we must check solutions. It's absolutely mandatory to check solutions when we square or cube or whatever, but especially when we take both sides to an even power. So when I put in 2, this is 3 and this is 3. But when I put in 9, I'm in trouble. Because 5 minus 9 is negative 4. A negative 4 will never equal 4. So I will say, no way, no, it doesn't work. In the original problem, this is not the original problem, right? In 5 minus q equals the square root of q plus 7, 2 works fine. 5 minus 2 is 3. Q plus 7 is 3. 9, the square root of 9 is 3. But 9 does not. 5 minus 9 is negative 4. But 9 plus 7 is 16, and the square root of 16 is 4. So this cannot work. Okay, so that's why I have to exclude this. It's called extraneous solution. It does not work in the original problem. Now, I do have students every semester who say, that's not true. No, they don't say it like that. I'm just trying to be funny. They say that's not true because the square root of 4, for example, is plus or minus 2. And I say, never. Please. That's not possible. What students remember, they remember x squared minus 4 equals 0. They remember x squared equals 4. And they remember taking square roots and writing plus or minus 2. But the plus or minus don't come from this side. They come from this side. Because it's the absolute value of x equals 2. That has two possibilities. X equals 2 or x equals negative 2. So in case you had that question on your mind, please understand the square root of 4 is only positive 2, not negative 2. The square root of 4 is only 2. Negative the square root of 4 is negative 2. But the square root of 4 cannot be plus or minus 2. It's confusing because we normally skip this step. So we solve this equation and we write that, and students think, oh, the square root of 4 must be plus or minus 2. No. This is the absolute value of x, and that's how we get there. But we omit that step. Not to confuse you, but we simplify directly here, but that's the correct step. Okay, so any other questions here? Do we need to look at other functions? Oh, that's not what I meant. I meant here. Do we need other functions, or we consider R finished and we move on to chapter 1 finally? Anyone else would like to pick anything or not?
I'm all right.
Should we look at any of this? Maybe we just solved something similar because it was in the way. But let's also look at maybe 79 quickly. And we move on. So we have P equals 5 over Q. And we have P equals Q over 5. Interesting. We're asked to find the equilibrium point. How do I find it? What is the starting point? What did we do a few minutes ago? Yes, go ahead.
Equal to each other.
Absolutely, absolutely. Thank you. 5 divided by Q equals Q divided by 5. Good. What type of equation is this now? And again, it's among these.
Rational.
Yes, of course. Thank you, thank you, thank you. So now I think I can recycle that. Yes, because it has the variable in the denominator. Not this one, but this one. It happens that this is a proportion. In a proportion and only in a proportion, I'm allowed to cross multiply. So 5 times 5 must equal Q times Q. How much is Q times Q?
Q squared.
Yes. So Q squared equals 25. And this is the shortcut. It doesn't mean that when I take the square of 25, I get plus or minus 5. No, they come from the other side. So then what do I get? I have to get two solutions. It's quadratic. Two solutions. Any quadratic has to have two solutions. Real, imaginary, I don't care. Two solutions, even if they're the same. So can anyone give us the solutions for Q squared equals 25?
Q equals 5.
two solutions.
Q equals plus or minus 5.
Perfect. Excellent. So now we have to decide. When I plug in 5 in here, 5 and 5, 5 over 5, 5 over 5. When I plug in -5, because we are talking about price and units, I will not include -5. I will say only Q equals 5. Although both of them work here, but we also look at the picture, right? So there is nothing on this side. Why? Because I cannot have quantity or number of units that is negative, and I cannot have price that is negative. So that's the reason why we write it, because that's correct, but I have to state only Q equals 5. If Q equals 5, oh, did I write the ordered pair before? Did I write the, I did not write. Did I write? I didn't. Okay, so we have to write the equilibrium point. So we determine Q, which is 2, comma. We have to determine what it equals to, right? The y coordinate. And we already have it here, but I didn't write it. So it's 2, right? It's 3. 5 minus 2 is 3. And when I plug in 2 here, it's also 3. So this is the equilibrium point. 2 units at the price of 3 per unit. $3 per unit. So we didn't finish. I didn't finish. Good. So we have Q equals 5. So the equilibrium point has 5, comma. We plug it in. How much is 5 over 5? So it's 1. 5 units at the price of $1 per unit. And that's the equilibrium point. And we can see it also, both of them. So right here. 5, comma 1. And on the other one, where was it? What did we get? We got 2, comma 3. That's the equilibrium point. Any questions? Any questions? Any questions for me? Anyone? Okay, we finally start chapter 1. I know I only have 10 more minutes. Don't let me go over as a token of respect to you, please. Because sometimes I get immersed in what I'm doing and I may not watch the clock. Okay, I'm going to stop.